Here we are discussing an important question from the chapter complex number. Question is, show that root 7 plus I root 3 upon root 7 minus I root 3 plus root 7 minus I root 3 upon root 7 plus I root 3 is real. Okay, we have already discussed in previous videos that if any complex number z which is denoted by a plus ib, this is a real number. This is a real number if its imaginary part b is equal to 0. In that case, then complex number z becomes simply a, since b is 0. So here we have to show that this expression is real. Here we will show that this number b, imaginary part, will be 0 in this expression. Okay, so let us see solution here. Here, for rationalizing the denominator, we multiply numerator and denominator by conjugates of this complex number. This is one way. And another way, since these two expressions are conjugate to each other, the complex numbers in these two denominators are conjugate to each other. Conjugate means only sign of this imaginary part is different. This is minus, this is plus. Then each of these two complex number is known as conjugate of each other. In that case, there is no need to multiply numerator and denominator with the conjugate of this. Automatically we will get this result when we will take LCM here. So let us start. Root 7 plus I root 3 upon root 7 minus I root 3 plus root 7 minus I root 3 upon root 7 plus I root 3. Here we will take LCM of the denominators. So LCM of the denominator, simply multiplication of these two complex numbers, will be LCM of these two complex numbers. So here root 7 minus I root 3 into root 7 plus I root 3. Root 7 plus I root 3. This is LCM of these two complex numbers. In a simple fraction, simple simplification of addition or subtraction of fractional numbers, what we do? We take LCM of denominators. Then if we divide this LCM with this number, how many times? This many times. So this number will be multiplied with this numerator. Generally we do in the simplification of fractions. Okay, so here root 7 plus I root 3 into root 7 plus I root 3 means whole square of root 7 plus I root 3, this whole square, and this plus sign. Similarly, when you divide this LCM by this denominator, root 7 minus I root 3 times, it will be divided, and root 7 minus I root 3 will be multiplied with this numerator. So square of root 7 minus I root 3, this whole square. Okay, let us simplify it further. In denominator, you see this is in the form of a minus b into a plus b. In the previous video, we have seen that this will be equal to a square minus b square, just like an algebraic formula. So here denominator will be root 7 whole square minus I root 3 whole square. And in numerator, we can expand it by using the formula a plus b whole square, a square plus twice ab plus b square. So this is root 7 whole square plus 2 into root 7 into I root 3, 2ab plus b square. So I root 3 whole square, correct? Similarly, expand this whole square root 7 whole square minus 2 into root 7 into I root 3 plus I root 3 whole square, correct? This plus and minus will be cancel out. And root 7 square is 7 plus I square is minus 1 and root 3 square is 3. So this is minus 3. Similarly, this is 7 and this is also minus 3. I square is minus 1 and root 3 square is 3. So this is minus 3 and denominator is root 7 square is 7 minus I square is minus 1 and root 3 square is 3. So minus 3 into minus is plus 3 and this is equal to 7 minus 3 is 4. 4 plus 7 is 11. 11 minus 3 is 8. 8 upon 10 cancel out. This is 4 and this is 5. So we are getting here 4 by 5. This 4 by 5 can also be written as 4 by 5 plus I into 0. You see here imaginary part is 0 and this expression is a purely real number. Okay. So therefore here we find that 4 by 5 is a real number. That is, the given expression is real number. That is, the given expression is a real number. So it has been proved here. Proved. Correct? Very interesting. Very simple. Hope you have understood it. Okay. Now we will see some more important questions. Remain in touch with these videos and share this video with your friends also. Wish you all the best.